Hi everyone, how to solve higher derivatives of function. Consider that y is equal to f of x. When we say higher derivatives, that is the derivatives of the derivatives. So the 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 the, the first derivatives is the derivatives of the function. The second derivatives, okay, the second derivatives is the derivatives of the first derivatives. The third derivatives is the derivative of the second derivatives. Okay, so let's have examples. Find the third derivatives of the following function. Number 1, f of x is equal to x raised to 5 minus x raised to 4 plus 2x cubed minus 6x squared plus 3. Find the third derivatives. So what is the derivatives of this function? First derivative is 5x raised to 4 minus x cubed, 4x cubed plus 6x squared minus 12x plus 0. Okay, so the derivative of this is this one. So this is our first derivative. And our second derivatives, f double prime, is 20x raised to 3 minus 12x squared plus 12x minus 12. So the second derivative is the derivative of the first. And last, the third derivative of the function is 60x squared minus 24x plus 12. So uh, the third derivative is the derivative of the second. Let's have more example. Number 2. Y is equal to 2x raised to 4 plus 3x cubed minus 5x squared plus 2x minus 4. First derivative of this is 8x cubed plus 9x squared minus 10x plus 2. Second derivatives, this is 24x squared plus 18x minus 10. And last, the third derivative, that is 48x plus 18. Again, so the third derivative is the derivative of the second. The second derivative is the derivative of the first derivative. And the first derivative is the derivatives of the function. More example, number 3. Y is equal to x squared times e raised to x. Find y triple prime or the third derivatives. This is a product of two functions. Okay, x squared times e raised to x. So we have two functions here. We're going to apply the u and the v. What is the first derivatives of what is the product rule? That is y prime is equivalent to u dv plus v du. So the x squared is our first function or u, and e raised to x is our v function. Okay. Following this pattern, so our first derivative is copy u, the x squared, times derivatives of v is e raised to x, plus copy v, e raised to x, times derivatives of u, that is 2x. U, this is our u. Just copy. Then the derivatives of u is e raised to x, plus copy v, this is our b, the e raised to x, times the derivatives of u, derivatives of this is 2x. Then let's simplify. So the first derivative is x squared times e raised to x plus 2x e raised to x. So we can factor out e raised to x, common factor. So y prime is e raised to x times x squared plus 2x. Then we can now find the second derivatives. We're going to let this u and v again. So this is our u and b. So product of two function. So we apply the rule, the udv plus vdu. So our second derivative is copy u e raised to x times derivatives of v is 2x plus 2 plus copy v, the x squared plus 2x times the derivatives of u is e raised to x. So let's factor out e raised to x. So e raised to x times 2x plus 2 plus x squared plus 2x. Then simplify. We have e raised to x times copy x squared, combine similar term, 2x plus 2x is 4x, then 2, copy 2, and this is our second derivatives. Then this is another u dv and v du. So e raised to x is our u, and x squared plus 4x plus 2 is our b. And let's apply again the product rule because we have two function, e raised to x times x squared plus 4x plus 2. Okay, apply the product rule. So our third derivative is copy u, the e raised to x, times derivatives of the function 2x plus 4 plus copy v, the x squared plus 4x plus 2. Then derivatives of e raised to x, this one is e raised to x. Then simplify. Ka-factor out e raised to x. So matitira sa loob ay 2x plus 4 plus x squared plus 4x plus 2. Then simplify e raised to x times copy x squared. Combine similar term x squared and 4x, that is 6x. Then 4 plus 2, that is 6. And this is our third derivatives. Next, another higher derivatives. Find the second derivatives of y is equal to e raised to x times cos x. So this is another product of two function. So because we have e raised to x times cos x. So the e raised to x will be served as our u and cos x will be served as our v. And let's apply the product rule, the u dv plus the v du. So what is our y prime? Copy u, e raised to x. Then derivatives of v is negative cosine, negative sine x plus copy v, cosine x times the derivatives of u is e raised to x. Factor out e raised to x, e raised to x times negative sine x plus cos x. That is our first derivatives. Next, find the second. Our second derivatives, let's apply again the u dv plus v du, but our u dv our u function will be the e raised to x. This is our u. And the second function, negative sine x plus cosine x, will be our v. Copy u, e raised to x. And then the derivatives of v is negative cos x minus sine x plus copy v, the negative sine x plus cos x times derivatives of u is e raised to x. Then factor out e raised to x. The remaining term inside is negative cos x minus sine x plus cos x. Copy e raised to x, simplify. Negative cos x plus cos x is 0. Negative sine x minus sine x is negative 2 sine x. Then simplify, we have negative 2 e raised to x sine x. So the product of e raised to x and negative 2 sine x. So multiply negative 2 e raised to x sine x. And this is our second derivatives. Oh. Number 5, find the second derivatives of the function secant x. So the first derivatives of secant x is secant x tangent x. Then, to find the second derivatives of the function, apply the udv plus vdu. This is the secant x will be served as our u, and tangent x will be our served as v, because secant x times tangent x. So that we apply the product rule because the function is a product of two functions, secant x times tangent x. Okay, so what is our u? Secant x. Then the derivatives of v, the tangent, is secant squared x plus copy v, the tangent x, times the derivatives of u, which is secant x tangent x. Okay, so copy u, then the derivatives of v, copy v, then the derivatives of u, then simplify. So we have secant cube x plus secant x tangent squared x. And that is the answer, second derivatives. Next, for number 6, this is also uh, derivatives of product of two function. So let's apply the product rule. The 3x squared minus 4 will be served as our u, and x squared minus 3x will be served as our v. So the first derivatives is u dv plus v du, or uv prime plus vu prime. What is u? 3x squared minus 4, and the derivatives of v is 2x minus 3 plus copy v, the x squared minus 3x, and then the derivatives of u is 6x. Then simplify. Apply the FOIL method, 3x squared times 2x, that is 6x cubed. 3x squared times negative 3, that is negative 9x squared. Negative 4 times 2x, negative 4 times 2x is negative 8x. And negative 4 times negative 3 is positive 12. So 6x distribute 6x times x squared, that is 6x cubed. And 6x times negative 3x, that is 18x squared. Then simplify. We have 6x cubed plus 6x cubed, that is 12x cubed. Negative 9x squared plus 18x squared, that is positive 9x squared. X, negative 8x, just copy, and positive 12. And that is our first derivatives. So this is our first derivatives. How about the second derivatives? Second derivative will be 36x squared plus 18x minus 8. And last, we are looking the third derivatives of y, which is 72x plus 18. And this is the answer for number 6. This is the answer for number 5. Okay, so that is the first part of solving higher derivatives of the function. So I hope you learned something. Please like, share, and follow my pages. There will be a part 2 of finding the higher derivatives. I hope you learned something. Bye-bye to everyone.